Now we will set the design load. So first we will define the load cases. It is also linear and static load. Now again, load pattern gives dead load 1 and live load 0. It is a self-weight multiplier. Okay, now we will select the beam. Object type beams, because this floor is going for another one. Now assign the frame load of distributed and gives its 4.5 kilonewton, and then its dead load, that is the load of the walls for all the beams, and click on OK. Now we will select slab and assign a shell load of uniform load. Its dead load is 3 kilonewton. If the building is simple, no other more live load. Here we can see that the beams load and live load. Now we will analyze the, first of all we will check the model, all the things. Before this, go for basement. Okay, now we will select joints, only joints. Here we can see that okay, nothing should be leave. Okay, now assign joints restraint. We will give it fixed support from the bottom, and now click on OK. So one thing more, that is design strip. Okay, we will add a design strip on story 1 and apply. So we can see that here a design story at x-axis, at b side both. Apply and OK. Okay, so here we can see that along with here we can see that the design strip is occur. Here we can see that here this is our design strips. Okay, now the check the model. We will select all things and OK. So here we can see that the full report of our model. It will take time for analyzing the model. So here we can see that V1 and V are overlap each other, overlap each other. So check it, select object, warning, untitled this. So one at V story 1, B1 and B7 are overlapping each other. So we can see, check it, B1 and B7. Here we can see that I think it's due to the basement. Okay, now run the analysis. First we will save the model. So okay, in document, create new folder, name it etabs. Okay, open and save, and save it here at project 1 G+1. We'll give the name project G1. Okay, our model is saved. And analyze. So you can see that this is a deformation. At any point we can see the deformation. It's too high deformation. Here -35, -39. It's depend upon L divided by 2000. Length is 800 and this is 1000. So now we will go for design. Select length combination. So first we will define the load combination. Okay, so define load combination, add default. So we have the both concrete frame and slab design. Okay, so these are our load cases. Select on OK. This is the best features of concrete frame load combination. Okay, it is automatically come for load combination. And what is this load combination? This is 1.5 times of DL and 1.5 times of LL, yani dead load or live load. So we can see here OS, yani these all are filled in shear. And one more thing here, this is I think overlap. Yeah, it's going for cantilever. So we will correct this. All the columns and upper beams are filled. So what we'll do, we will change the design section. Okay, now delete this or come for analyzing. First we will delete this part, this thing. Okay, now delete this beam first because of overlapping, outflow. So again we draw a beam. Okay, now first we will define section properties of frame section. So we will modify it. Now modify or show properties. Okay, we will give this 350. Depth is going to be 350 for the beam. Select on OK. Okay, similarly on columns, because some columns are also filled, so we will increase it from column, it's 400. All the other things are same. That's 400. 450. Okay, that's 450 because it's filled in shear. Okay, again modify, that's 450. 230 by 450. Okay, Okay, now we will go for select option, select object type, select beams. Okay, close. So all the beams are selected. Now we will delete them. Again we will select objective type, column. All the column are selected and go for delete. So we can see that all the columns are delete. Again we will design it. So now select on beam part and it's 230 by 450. So now use this part for beam of 1 story. We will use it at 1 story again, and now it's 1 story and 1 story. So here we can see that on 1 story these all beams are selected, and again this all the beams are selected. So we will go for bottom part. Okay, again we will use same thing as a row. Okay, now we will draw the beam properly. Okay, now first go for upper part, all story, use. Okay, here we can at 3rd meter. Now select column, give them property and select the parts where column is to be drawn. Okay, now we will check the load. Here no load is defined, so now again we will apply the load for beams and column. Okay, now again select object type, joints, select, close, assign joints as a fixed. Okay, fixed, apply. Okay, so all our joints are fixed. Now we will again apply load. So select beams, assign frame load of distributed, and this frame is 4.5 kilonewton. Now we will apply this load per meter square. Okay, now select the slab. So slab is at our 3 meter point. We will select the slab, assign cell load, uniform. Okay, it's 3 kilonewton. So whole slab we will assign the load of 3 kilonewton. Okay, we can see the loads 3 kilonewton per meter square. Now first we will check the model. Our model is okay or not. Okay, so here we can check our model, that is to be. So we will see that here is no warning to be generated. Now again we will analyze the model. After analyzing, we are designing the model. So here we can see our model is design. First analyze, then we will design the model. So waiting for it. Okay, now add a new window, so we will see it, the deformation. Now it's less than 20. Okay, now we will go for designing part. Select load combination again. So we have our load combination, pop load combination. Go for designing. So now it will design the. Okay, here we can see that our few columns are this middle part and this middle part. This middle columns are failed. Okay, share, these are filled in parts. Here we can see that on the corners of this part. Okay, we will generate a report. Okay, so we will get the report for this and check where it is failed. Information required exceed maximum allowed, it will failed in moments. ओके, तो रिक्वायर्ड रिक्वायर हमारा कितना है, मिनिमम रिक्वायर्ड है, तो ये क्या है हमारा मैक्सिमम है, रेनफोर्समेंट इसमें हमारी मैक्सिमम है. तो फॉर दिस वी कैन click on OK. So we will modify. Okay, so design concrete frame. Okay, first we will see that here 6 concrete members are filled, so we will select them. Okay, here we can see that there is no load on the upper middle part of the body, so we will have to now remove the load again. Okay, so on this part we will see that no load, so select it, assign frame load distributed, or we will put it at 0. Okay, now apply and close. So on this part there is no load. Now again analyze, run the analysis of this model. So the model is to be analyzed. So we can see the deformation at each and every points. Now go for design and concrete design, check the design. Again these members are failed due to the large deformation. Okay, so we will change the area of the 6 side members. Now again okay, go for section property, frame section. Okay, add a copy of the beam. Okay, it's going to 350. Now we will, okay, once more we have to change the column sizes. Okay, change the column sizes. No, column is okay. I think we will have to change the beam sizes. It's 300 by 450. It's 300 by 450 because 230 is too less. Okay, now select, first we will select all the beams, select object type beams, select, close and delete. Okay, now we will again use same properties, same function, same things. Beams, beams, again beams. Okay, okay, and okay. So now we will assign a load. Select object type, it's beam, select, close, assign main load distributed 4.5 km, apply, close. So select this beam, 1, 2, 3, 4, 5 and 6. Okay, first we will, okay, now assign frame load distributed, it's 0, apply. These are load free. Now we will check that on slab we have already applied the load. Now analyze, check the model. Okay, so our model report is to be shown. Okay, now go for analyzing part. And now again design, concrete frame design, start the designing also. Again these are beams are failed. Okay, so what will we do? This beam is failed in exceeding the area, so select this beam, or we must draw the beam through here. Okay, first delete all the beams. Okay, now we will develop as a continuous beam. Maybe due to this long span of 8 meters, this may be failed. So we will do one more thing. We will draw the beams like that. Also in this direction. start again the beam. Okay, and on this side this will be okay. So no load is required on this beam, only self weight. So first we will check it. Okay, our model is now we will run the analysis. Okay, now go for designing part. Start the designing. Okay, now you can see that here all the things are okay. It's going to be okay. Okay, now for design for slab part. Okay, we will see one more thing here. Close it. Okay, we will see each and every beam and column shapes. That's okay. Again, if we want to see other thing like display design info, go for display design info, longitudinal reinforcement, rebar percentage, apply. So we will see that it's all R 0.45, 0.45 and 0.45 approximately 119. Nobody is more than 4% as per our Indian standard code. So here we can check it. All the percentage should be in less than 4%. So our structure is to save. Again, we will also check others like shear reinforcement. Okay, so the shear reinforcement areas is all are this. We can here see PM interaction ratio, column PM interaction ratio. It's not much more. It's about less than 1. Both the ratio is less than 1. Okay. Now beam column capacity ratio. So is not required. Column beam ratio also not available. General reinforcement detail. So here we can see that the general reinforcement detail are 423 to 828. This is the area of the reinforcement. And identify PM failure is not applicable here. No PM failure, no shear failure, and no any type of other failure. So we can see that our structure is frame is good. Okay, now we will analyze the design the slab. Okay, so concrete slab. First design story, it's 1 story. Okay, and again design, start designing. So our slab design, here we can see that the bending moments of the slab. Okay, again similarly we will check for display flexure design. This is our flexure. It is based on finite element based. If we want to see the finite element based on top bar, so we can see the top bar. Again, if we want to see that, select the design, top bar, bottom bar, then apply. So we can see the bottom bar effect. Okay, if our average and peak, so our average is here and peak at the this corner, so we can see that the peak side of the our slab. Now if we want to see on the concrete slab, check for punching, it's not visible here. If we want to check the crack width is applicable for due to the dead load, our main load is dead load, so we will apply. So here we can see that some minimum cracks are developed, that's enough, that is less than, it is very less. If we see, it's here some maybe cracks are developed at the center of the our slab, so it's all over our slab is okay. Now for our detailing, we will go for one more thing we want to see in our next lecture. So first it will show the full report of detailing, that we will see on another lecture.